When we talk about headphones frequency response, we talk about the flat frequency response or natural frequency response, and some semi-professional headphone user wanted the flat, colorless, transparent frequency response. They think if headphone can output such frequency response, it will be transparent. It means the sound have not been colored by the headphone. But we're going to dig a little bit deeper into this perspective. This curve is the equal loudness contour from the ISO, International Standard Organization. It means if the difference between human and machine at the acoustic sensitivity, it means from 10 Hz to 10 kHz, if a machine generates the frequency, generate the sound at a specific frequency, swap from 10 to 10K until 20K Hertz, the frequency, we are not going to feel the same volume. We are going to feel the volume is changing from 10K down to 10. And this curve will be different for different individuals, for different ears. This is the curve, and the y-axis is sound pressure level in decibel. Sound pressure, acoustic pressure, is a measurement. It's a logarithm measure. The reference measure is the reference sound pressure P0. What is P0 sound like? It's roughly the sound of a mosquito flying 3 meters away. A mosquito flying at 3 meters from the listener. It's the reference sound, audible sound. So this curve is an average curve, and it's different for different individual, for different ear. Then how we measure headphones frequency graphic, the chart. It actually has an human-related transfer function to compensate for the human sensitivity for different frequencies. And this is the result of the measurement. This is an Sennheiser HD 580. It has a very good shape from 10 Hz to 1K Hz, and dropped a little until 7 kHz. Then it has turned up to about 10 kHz. It's actually a very good curve. And this is Bear Dynamic dt1350, the curve. We can see it has a drop at the bass range from 100 Hz to 200 Hz. It has a drop. So some music listeners prefer dt1350. They think it's a flat frequency response. No, it's not a flat frequency response. And many listeners will notice it's lag bass. It actually isn't lag bass, but has a drop from above 100 Hz to 200 Hz. So many listeners will feel the lack of bass. It's actually a little bit lack of mid bass. 100 to 200 Hz mid bass, and the rest of the curve is quite good. It gave a slight smooth slope from 1 kilohertz to until 7 kilohertz. Then it has spark. If we watch more higher-end headphone, even better than dt1350. dt1350 and Sennheiser HD25. They are already good enough as a portable headphone. If we are going to see the frequency response curve for those headphones purposely used in-house, such as Sennheiser HD800 or 650 or Beyerdynamic 880, 770, they will give much better frequency response chart. The curve will be much better. This is a Skullcandy Rock National Aviator, another headphone, and tested by Inner Fidelity. I learned Inner Fidelity will add the effect of HRTF, human head relative transfer function, to compensate the curve, to compensate this curve, because human ear, fleshy ear, has frequency sensitivity not flat out. We have a curve respond to different frequency input, the sound input. So to test headphone, we need to compensate it. The golden curve might be this way. It will amplitude a little bit, a few decibel on the 300 Hz, and then flat out. No headphone can achieve this kind of curve, even for Sennheiser HD800. This is headphones frequency response curve and SPL, sound pressure level, and human ear sensitivity for different frequencies. But even for the golden curve, it's not everything for a headphone, because we know different instruments give different tone in the same frequency range. In the range, they are totally different. They have different timbre. The feel of the same frequency is different. So for a headphone, the frequency response curve is not everything. It's actually a misleading concept currently for most headphone listener. Even a headphone with close to golden curve, it might be not as good as this one. We can see that the dt1350 is far from the golden curve, but we know that it sounds quite good. If we say the Sennheiser HD25, we can say HD25 will have a bump, a bump at about different to the dt1350. HD25 will actually have a bump at around 150 Hertz, and it will give a little bit earlier roll up at before the 7 kilohertz. But HD25 still is a very good headphone. It's far away from the golden curve. So the curve, the chart isn't the only thing. It cannot totally equal to the headphone's performance. For example, the headphone can have clarity when it's reproducing sound. Okay. Basically, we talk about the human sensitivity, human ear sensitivity, and headphones frequency response curve, and the headphones performance. So we know that, put it simply, headphones frequency response curve not equal to the headphone sound quality. It can tell a lot about the sound signature, but it's not equal to the headphone sound signature. Far from the completeness. Okay. Thank you. Thanks for listening. Thanks for watching. Hope this information is helpful. Okay. Thank you. Bye bye.